Hi everyone, this is Panyam, your physics dude. Welcome back to my channel again. Today, in this video, we are going to learn what is a vertically projected body. Then, what are the examples that we see in the real world? Then we learn what is time of ascent, what is time of flight, and what is the velocity with which the vertical projected body touches the ground. Then we'll see a body projected from the top of a tower. Then we'll see what are the graphs related to vertical projected body, all that. So in this video, I'm going to explain all these concepts. Yeah, before I start my lecture, please subscribe my channel. If you really like my content, share with your friends and do not forget to click the bell icon for more updates. I all wish you a happy physics learning. Let us start the today's lecture. Yes, I strongly believe if you learn physics, yeah, it definitely accelerates your life and physics makes your life more beautiful. Okay, let's begin today's lecture. So, first of all, what is a vertically projected body? What is that? Why some force required to project a body? First question is force really needed for a body to move? So many of us think that yes, we require a force to move a body. In the previous class, I explained about a freely falling body. Remember, I just dropped a body, initial velocity is 0. So in this case, the body is falling freely. I'm not throwing it down, I'm not pushing it down. Because of gravity, the body is moving. But can I do the same thing in the upward case, the body projected upward? That means I have a body on the ground. It is there on the ground. Can it go by itself? So can it reach some height by itself? The answer is no. Why? Because here there is some resistance. What is that resistance? Earth is opposing the motion of the body. There is a gravitational force. So if this force is not there, body can move easily, it can fly. That's what we see. If gravity disappears, everybody starts flying. So we require force to overcome this, to continue, or you want to accelerate, we require force. But if you want to move with uniform velocity, no force is required. See, when we want to project a body, why we need some effort? Because the body is moving against gravity. The gravitational force is acting downward. So for that reason, we have to apply. So we all have learned what is this gravitational force. The force with which Earth pulls everything towards itself or towards center. So we call it as attractive force because Earth attracts everything towards the center of the Earth. And here we should understand some examples. So we all know ball thrown up returns back to Earth due to gravitational force. We can see in this example. This boy is projecting a body up, a ball or something. It is going up, up, up. Why it is somewhere it is stopped? Because this body is not moving, I mean, it is not accelerating. It is moving as it is moving against gravity. This body is decelerating. So when the body decelerates, its velocity keeps on decreasing. So its velocity becomes 0 at the highest point. Then the direction of motion have changed. It was like this initially, then it is coming back. So that's the reason why whatever the body you project up, it has to come down. That's what is all important thing we should remember about this body. And here, as I said, we require only force for continuing the motion. here we should understand an important point here. A force is only required to maintain acceleration. If you don't want to accelerate a body, no need of force. And in the case of a projectile that is moving upward, there is a downward force and a downward acceleration. That is, the object is moving upward and slowing down. That's what I said in this. Here in this, there is a downward force and there is a downward acceleration. So when we project a body, it is actually going against this downward force. It is resisting the motion. That's why we need to impart some velocity in order to project it up. If you don't impart some velocity here, the body cannot rise up. Yes, there should be some velocity here. Otherwise, the body cannot go up because it has to overcome. Then why it is coming to rest? Because this is constantly pulling. That's why somebody has to stop. So what is a vertically projected body? Any object which is thrown up with some initial velocity. That's what we can call it as a vertically projected body. Let's see some real-time examples or examples in the real world. You might have seen many adults throwing their kids just for fun's sake. They'll throw the kids and they're very sure they know that these kids will come down. So they'll go up, their velocity becomes zero, then again they'll come down. So they'll project their kid with some velocity and they'll come down with the same velocity but in the opposite direction. So here example of vertical projected. You can see a dog jumping into it. So it also requires some velocity. When it reaches the highest point, velocity becomes zero. Again the dog will fall down. And some of you, I mean, it's a common example. We see that these dolphins are jumping from the surface of the sea, then they'll jump down. This is also a vertical projected body. Yes, many kids like to play on this trampoline. So here is also very, good example of a vertical projected body. So the moment you jump onto this trampoline, you again will jump up. So it is a vertically projected body. The woman jump onto this, still once again rises up because of the reaction produced by this trampoline. It's a highly elastic. And as a kid, you might have seen a beautiful story about the fox which jumps to catch up these grapes. So it has to jump. It needs some initial velocity. Just by staring at the grapes, it cannot catch them. The fox has to jump up, what to call it as, to catch the grapes. If the velocity of this what called fox is very less, it cannot what called as catches this grapes. So it has to need some velocity in order to catch the grapes. And most of the students might have learned about this 5 little monkeys. So the rhyme goes like this. There are 5 little monkeys that jumping on the what to call it as bed. So what this rhyme is all about? 5 little monkeys jumping on the bed. One fell off and broke his head. Mama called the doctor. Doctor said, no more monkeys jumping on the bed. So the rhyme goes like this. So it is a beautiful example for a vertically projected, but they'll jump onto that, they'll go up and they'll jump down. Okay. So like this. So these people are jumping down, so they're freely falling. Then because the bed is elastic, they'll jump up. That's how usually the kids play on the bed. So like this, we have wonderful examples we could talk about for vertical. These are all the bodies under gravity. This even vertical projected body is also under the gravity only. Now let's get into some mathematical part of what called as this vertical projected body. Let's learn what are the equations of motion for a vertically projected body. We all have learned about this equations of motion. V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to AS, and at last Sn is equal to U plus A into N minus half. Very simple. We just apply the conditions, then we can get all the equations of motion. So as I said, for a vertically projected body, yes, the body is projected with some velocity. So as it is going up, it is going against gravity. We take g as negative. And I told it reaches some height. So in this case, displacement we take as some h. So simply put these conditions, the equations will turn up like this. Remember, these are before reaching the highest point. I can write v becomes u minus gt. There is some velocity before it reaches the highest point. The second equation becomes h is equal to ut minus half gt square. The third one, v square minus u square 2s. And the fourth one, Sn is u minus g into n minus half. So we are not writing any new equations here. We are just substituting the required conditions. So for a vertically projected body that is as it going against gravity, in the place of a put minus g, and in the place of displacement put h, you will get all the equations. Now let's discuss about what is time of ascent. So let's see the definition of time of ascent. Very simple. The time taken by the projected body to change its velocity direction is time of ascent. Otherwise, simply we can say the time taken by the vertically projected body to reach the highest point. What is happening at the highest point? The direction of motion changes. Initially going up, at the highest point velocity becomes zero. All of a sudden the body start moving in the opposite. That's why we are saying it is the time taken by the projected body to change its velocity direction. Either way can differ. Let us take this example. Suppose this man is throwing this ball with, say, let's take some velocity u. So what happened? This ball will raise up and somewhere its velocity becomes zero. This is called the highest point. Then this time taken by the ball to reach the highest point, let's take this is the h is the distance traveled. We call it as time of ascent. Very simple derivation part. Let's take the equation v is equal to u plus at. So velocity is zero. There is initial velocity as it is going up. So gravity is downward. So minus g time is called time of ascent. So the equation for time of ascent is u by g. The equation of time of ascent is u by g. It's a very important point to understand. The time of ascent depends on velocity and it depends upon acceleration due to gravity at that place. So higher the value of gravity, less is the time taken because the body cannot reach a greater heights. It will compress in less time because there is a more gravitational force. And see, that is the reason if you jump on Earth and Moon, we jump for less time on Earth. We compress in less time on Earth because on Moon, as we discussed in the last lecture, the acceleration due to the Moon is 1/6 of Earth. That means if you jump on Moon, will be in air for more time when compared to Earth because on Earth acceleration due to gravity is more when compared to Moon. So will be more time in air on Moon when compared to Earth. So it depends upon acceleration due to gravity also. Now let's see what is meant by time of flight. So generally time of flight means how long the body remains in air, how long it travels in air the moment it leaves the ground. So the total time for which a vertically projected body remains in air. Let's take this example of a ball. I have a ball. So what I'll do is I'll project the ball as in the same, just like the above example. So let us project the ball again with some velocity u. So what happens? The ball will go up and reach a certain point where its velocity becomes zero. So what this ball will do after going there, the ball will take, so we can say that this ball after reaching the highest point, because the gravity now start pulling it down, so the direction of motion changes. So here the velocity of the ball is 0. So because final velocity is same, so now it starts falling down. So it will reach the ground again after some time. So we call this as time of ascent, and we call this a time of descent. In the previous case, in the previous lecture, I explained what is time of descent. If whenever a body is released from certain height, then the time taken to reach the ground is called time of descent. So time of flight means the total time for which this ball is in air. So while going up, it was for TA, and while coming, it was for TD. So time of flight simply means T is equal to time of ascent plus time of descent. Okay, so this V is nothing but T is equal to what called as, we'll get the expression once I explain maximum height. I'll come to what is the expression time of flight. So for the time, just remember time of flight is simply time of ascent plus time of descent. Now let's see the case of what is maximum height. So let's understand the definition of maximum height. Maximum height, again, very simple definition. The maximum height is the distance after which the velocity of the body becomes 0, or the direction of velocity changes. The same thing I explained. So again, let's take this apple. So when we project this apple from certain, from the ground with certain initial velocity, let us take. Initially, this is on the ground. I am projecting this apple again with some velocity, say u. So this apple will go up. It reaches some height h. By the time it reaches that height, where the whatever the displacement it covered vertically, by the time its velocity becomes 0, or the velocity direction changes. So this height reached by the body is called maximum height. So let's use this equation of motion. V square minus u square is equal to s. So in this case, the final velocity is 0, body projected with velocity u square, and again the body is going against the gravity, so minus g. So or we can say it is going against the gravity. This is the direction of gravity. This is going up, so opposite. So 2 times minus g. And how much is the displacement covered h? So simply I can write u square is 2gh, and h is equal to u square by 2g. Again, as I said in time of ascent, here also the maximum height reached by body depends upon the velocity with which it is projected, and at the same time it is inversely proportional to acceleration due to gravity. So if we project a body with the same velocity, if I project a body with the same velocity on Earth, on Moon, suppose if this is Earth, this is Moon. So what happens? When compared to Earth, the height reached by the body on Moon will be greater. H2 greater than H1 because G2 less than G1. So lesser is the gravity, more height a body can reach on projecting with the same velocity. I said both the bodies are projected the same velocity, one on Earth, another on Moon. So the body projected on Moon reaches a greater height when compared to body on Earth. So or simply I can say it is easy to jump up on Moon when compared to on Earth. So higher the gravity, higher the what called as less height you can reach. So since we got the expression for max height, now I can write time of descent in other form. So time of descent in the last lecture I explained, time of descent is actually root over 2h by g, where h is the height reached by the body or max height we can say. So what is that h we got? U square by 2g. So time of descent can also be written as 2 upon g times u square by 2g. So when I cancel this sorry, 2, and yeah, 2, and there is a g still left. It is u square upon g square. So time of descent can also be written as u by g. So from this, I can say that for a vertically projected body, so what is time of ascent? I said time of ascent is u by g, and time of descent is also u by g. So very important point we all can understand. For a vertically projected body, very important, time of ascent is equal to time of descent, which is nothing but u by g. But we need to understand an important condition. These things are equal. Time of ascent is equal to time of descent only when there is no, when we don't consider a resistance. When we don't consider a resistance. So all the equations that we are deriving in kinematics, keeping in mind that there is no A resistance. We don't consider A resistance unless until it is specified in the problem. Otherwise, no need to consider A resistance. If we consider A resistance, they'll be different. We'll discuss them in later. So here an important point is to understand time of ascent is always equal to time of descent, which is equal to u. Again, I'll go back to time of flight. So what is time of flight? I said time of flight is the total time for which the body remains in air. So now I can write this u by g, and this is also u by g. So therefore time of flight can be written as 2u by g. The expression for time of flight is 2u by g. Now we can get some important relations here. So I want to find out, or I want to express maximum height in terms of time of flight. So just now we got maximum height as u square by 2g. Now I want to write down the time of flight max height in terms of time of flight. But what is time of flight? 2u by g. This implies u is equal to gt upon 2. So let's substitute here. So this becomes g square t square 4 into 2g. So simply I can say 8g t square. So this is an important application. When we solve problem, we can use these identities. So 1 by 8 g t square, or sometime we can say reverse. Time of flight in terms of maximum height. There's a square root here. This is the time of flight in terms of maximum height. And this is maximum height in terms of time of flight. So these are some identities we generally come across while solving problems. These are very, very useful. So we discussed a very important points. What is time of flight? What is time of ascent? And then we discussed about what is maximum height, what are the different expressions, all that. So let's see some important points to ponder. We need to have a clear idea about, let us combine both freely falling body and vertical projected. We'll discuss some important points. Yes, the first point is very, very valid point. So what is this? The speed with which a body projected up is equal to the speed with which it comes down. Again, an important aspect here, when we don't consider a resistance. If we consider a resistance, they'll be different. So we have a proof also there. Let me show you what does it mean. Suppose, as I said, I project a body with some velocity. So let's take u. So it says that it goes up, we all know. Velocity becomes 0. Then the body starts moving down and finally touches the ground. So with what velocity I projected u, so here when it project, let us take v. So we need to prove that v also is equal to u. That's what we prove. So we know v is equal to u plus at. I'm calculating velocity for during time of flight. So v is equal to u minus g because the body going upward. So during time of flight. But what is time of flight? Just now we discussed 2u by g. So ultimately v becomes u minus g times 2u upon g. So g cancel. This is minus u. A very important identity we should understand. So what did I prove? With whatever the velocity we project a body, it returns to the ground with the same velocity. But what does that minus sign? It is in the opposite to the original direction. With whatever the velocity project a body touches the ground with the same velocity. That's an important point. Second point, let us see next one. The magnitude of velocity at any point is same whether the body is moving up or down. So what does it mean? Let's see another example. Suppose same, let us take a body projected from the ground with a velocity u. So it will go up. Again the highest point, velocity becomes 0. Then it starts falling down. Here the velocity is 0. Now it is falling, and just now I proved that here also the velocity is u. Suppose after some time, let us take this point. If this is the velocity here, somewhere the velocity will be v. This is while going up. In the reverse journey also at the same point, if you take the same point, here also the velocity is v minus v. So if you look at here, what is the velocity of the body? 0. Here also at the same level, the velocity is 0. Here at the same level, velocity is 0. For a vertically projected body, the velocity, the magnitude of velocity is same while going up and while coming down. This is a very important point. We can use it for solving problems. So for a vertically projected body, velocity is same in magnitude at any level while going up and while coming down. Again, this is when no air resistance is considered. All these vertical projected or freely falling equations are applicable only when air resistance is not considered. Now let's move on to the third point. What the third point says, for complete journey, the change in velocity is 2u. Just you look at this one. So what is change in velocity? Final velocity minus initial. Final is u minus u. That is actually minus 2. But we want only magnitude. If you take the direction, yes, we need to put minus. So if you want only the magnitude of velocity, it is 2u. For the complete journey, the change in the velocity of the projectile is 2u. Right. Next, let's move on to the next point. Yes, obviously momentum. Momentum is nothing but mass into velocity. So just multiply that with, you'll get momentum. Change in momentum is 2mv. So this is a very important applications is there. We'll discuss in the next lecture. Next, let's see the next point. These are all very important points to remember. The next point says the distance covered during the last t seconds of ascent is half gt square, and for the last second it is g by 2. For any velocity of projection, what does that mean? Let me explain. So again, take an example. A body projected from the ground with a velocity say u. So it will rise us up, and finally the velocity becomes 0. And let's take height h. So we use the equation s is equal to ut plus half gt square. So here we say an important point. What is saying is asking only the distance covered in the last t seconds. I want to find out this t seconds. So we always suggest that if you want to find out the distance covered by a vertically projected body in the last t seconds, we should know what is the velocity at this point. But it is easy for us if you reverse. Imagine a freely falling body. As I said, for a freely falling body, initial velocity is 0 and this is the t second. So we can say that the distance covered by a vertically projected body in the last t seconds is same as the distance covered by a freely falling body in the first t seconds. For this it is last t second, for this it is first t second. So we can say that S is equal to 0 plus half gt square. So a vertically projected body covers a distance of half gt square in the last t seconds. So you should not confuse between the last t seconds and total t seconds. Suppose they ask a question, what is the distance covered by vertical body in t second? Then you simply use the equation ut minus half gt square. This is different from this. This is for last t second and this equation for t second from the beginning. So whenever they ask it is, so an important point we should understand here is the distance covered by a freely falling body in the last t seconds. I mean the last is same as distance covered by vertical waveport in the last t seconds. Suppose if I keep t is equal to 1, yes, simply g by 2. So a vertically projected body, if I take g as 9.8 is 4.9 meters. So a vertically projected body will cover a distance of 4.9 meters in the last second. Otherwise, a freely falling body will cover a distance of 4.9 meters in the first second. The same logic we can apply in the reverse also. Suppose if we take this a vertical projected body and here the highest point you project with the velocity u. So again, if we take this the reverse, it's a freely falling body. It falls to the ground. So if you look at take t seconds here, take t seconds here. So the distance covered by a vertically projected body in first t seconds, this distance is same as the distance covered by a freely falling body in the last t seconds. If for it is first t second, for freely falling body is last t. So we can simply say S1 is equal to S2. So the distance covered by a freely falling body in the last t seconds is same as the distance covered by a vertically projected body in the first t seconds. So these are very important points you should remember while solving problems. Let's move on to the next point. Distance traveled in the last second of total journey. That's what I said. Simply use the formula ut minus half gt square. Simply put last 1 second. So u minus g by 2. Like this also we can write. If you know the u value, we can calculate in this way also. Now, these are all the body projected from the ground. This discussion is only for the body projected from the ground, the time of ascent, time of flight, all that. Now, instead of projecting a body from the ground, if I project it from the top of a tower, what will happen? A body projected from the top of a tower, let us see what happens, and we have to discuss some important points here. So let us consider a tower, and the height of the tower is a letter h. I have a tower and height of the tower is h. Now I am projecting a body from the tower with a velocity u. Again, it will raises, velocity of the body becomes 0 at the highest point. Then this starts moving in the reverse direction. An important point you should understand, by the time it reaches, its velocity is again minus v. Because that's what I said in the previous case, with whatever velocity the body reaches, projected, it touches the same point with the same velocity. Then from there, it comes down and touches the ground with some velocity cv. See, if I consider the same level, velocity is same. This is a different point. Okay. Now here we need to follow some sign conventions. Heights covered in the upward direction are taken as positive, and heights covered or distances covered, displacement in the downward is taken as negative. Upward displacement positive, downward displacement is negative. So since it is upward, let's take positive, and the same distance will be covered in the downward direction, and let's take that as negative. So what is the first question? What is the displacement of the body for the total journey? Let us calculate this part. So displacement is nothing but it started from here, it went there, and even h is also negative because it is the distance on the downward direction. So s become plus h minus h again minus h. So these two cancel. So the total displacement is minus h. That means minus sign indicate that the body is traveling finally in the downward direction. Suppose if they ask you what is the total distance, if you want to find the total distance covered by the body, yeah, h distance is a scalar. Simply we can write distance is equal to h plus h plus h. Since it's a scalar, no need to follow any conventions. No need to follow any conventions. What is the maximum? See, if you look at, since a body projected from this with a velocity u, what is the height reached? H can be written as u square by 2g. So the same way I can write here, if you want to find out the total distance traveled, 2 times u square by 2g plus h. These two cancel. Ultimately, I can write the total distance is also equal to h plus u square by g. Now, what is the maximum height reached from the ground if you consider? From the ground, if you look at the body, if I take this as a reference point, from here to here it is h, from here to here it is h. Again, there is a small h, so h plus h. So max height reached from the ground if you want to calculate. So h plus h, which is equal to h plus u square by 2g. Now let me calculate what is the time of flight. Time of flight means the time taken by the body to reach the highest point, then again to come down. So use the formula s is equal to ut plus half at square. So what is the total? S is the total displacement I got minus h. So minus h, and I project with velocity ut. It is going up, so minus ut square. So here we are getting an equation in terms of time as simultaneous quadratic equation. Let us simplify that further. Yeah, I'll bring it this side. So or we can write this as minus 2h is equal to 2ut minus gt square, or simply I can write gt square minus ut minus 2h is equal to 0. So this is a quadratic equation. We need to get the value of time. So I'll write t is equal to minus b means 2u plus root over b square, again 4u square minus 4ac, 4a is g, c is minus 2h whole upon 2a, that is 2 into g. So this I can write t is equal to 2u plus, we take only positive value, I'll tell you later why. If I take 4 common, it becomes u square plus 2gh whole upon 2g. If I take 2, 4 out, it becomes 2. So I'll write this time of flight is nothing but 2u plus 2 root over u square plus 2gh whole upon 2g. So simply we can cancel 2 here. So ultimately the time of flight for the body projected from the tower is u plus u square plus 2gh by g. This is a very important equation. Yeah, this can be written in many different forms. The same equation I can write. Usually this is given in different forms. Let me explain. So T is equal to, I can take this u upon g plus 1 by g times u square plus 2gh. So T is equal to u by g plus, if I take u square common, it become u again. So u by g square root of 1 plus 2gh upon u square. So overall, if I take u by g common, u by g 1 plus, yeah, it's 1 plus square root of 1 plus 2gh upon u square. So sometimes the same question will be given in exam like this. For a vertically projected body, the time of flight is also can be expressed like this. Instead of giving like this, they can give you in this form also. Now let's see the next one. What is the next one? What is the velocity of the body on reaching the ground? It's a very simple derivation. Now let us take this point. As I said, when it touches the ground, its velocity is minus u. I want to find out this. Simply apply the equation v square minus u square is equal to 2s. So this is v square. Anyway, minus u whole square is u square only. Body is coming down. Here g is positive. So this become u square plus 2g into h. So we have to take that displacement. So therefore, final velocity of the body is nothing but u square plus 2gh. Remember, some students may be worrying why I'm not taking minus h. Minus h is only for calculating total displacement. Here we can use the displacement only, it's positive only. So this is the final velocity of the projected body from the ground, from the top of a tower. Now, just I told you the time of ascent is definitely the velocity v will be greater than u. Why? Because it is u square plus some value is there. So when I explained this time of ascent, I said u only plus. Why? Because inside we got u square plus 2g upon g. So what is this u square plus 2ghv? Since v greater than u, it cannot be negative. So otherwise we can write the same as u plus v by g. So these are the some important mathematical what called as points you should remember regarding body projected from vertically projected. Let us see some graphs regarding a vertically projected body. First, let us see the first one, ST graph. So very simple. We use the equation S is equal to ut plus half at square. We know that when t becomes time of ascent, when t becomes time of ascent, that is u by g, let us calculate what is this s. So s becomes u into u by g minus, because going up, g into u by g whole square. So s is equal to u square by g minus, this is g by 2 into u square by g square. This, if you look at g cancel, this become actually u square by 2g, which is nothing but maximum height. When the time is time of ascent, distance traveled is h maximum. Now when time is equal to time of flight, what is the distance? S is equal to, again I use the same formula, u into time of flight is 2u by g minus half g into 2u by g whole square. Let us simplify that. 2u square by g minus 1 by g into 4u square by g square. So this I can write it as 2u square by g minus, this also same, 2u square by g. So by the time it completes time of flight, its displacement is 0. Again, even when I keep t is equal to 0, displacement is 0. With these three limits, I plot ST graph. How it looks? Let us take S on y-axis and t on x-axis. So when t is equal to 0 and t is equal to time of ascent, t is equal to time of flight. When it is at t is equal to time of ascent, it is the maximum value, that is u square by 2g. So remaining, it increases first, then the value first it increases, becomes maximum, then falls down, and finally becomes 0. This is the shape of ST graph for a vertically projected body. Now let us see what is the VT graph. The second one is VT graph. Very simple. Yeah, before I reach that max height, I'm plotting the graph. So we know that V is equal to U plus AT. When T less than time of ascent, then I can write V is equal to U minus GT, or V is equal to minus GT plus U. It is of the form Y is equal to minus mx plus, or we can do one more thing. Here also we can calculate the velocity of the body at different points. So when again if I take, if t is equal to 0, very important, v is equal to u, and when t is equal to time of ascent, v is equal to u minus g into u by g, again 0. When t is equal to time of flight, v is equal to u minus g into 2u by g. This is minus u. So what does that mean? Let us understand. When initially a body projected with a velocity u, and this is how the VT graph looks. See, that means initially the body has some velocity. This is v, this is t. So remember, in this case, when t is equal to, there is some velocity. Here it is, there is some velocity, which is nothing but u. Then after time of ascent, the body will be at the highest point. So the velocity becomes 0. So then again, the velocity keep on decreasing. The velocity increases, again increases. It increases like this. So this is time of ascent. This is time of flight. This is minus u. This is plus u. And here it is after time of ascent, highest point 0. Then after time of flight, it is minus. So this is the shape of y is equal to minus mx plus a graph. Now let us go to the last one, that is AT graph, acceleration time graph. Very, very simple. For a vertical projected body, we take only minus for the upward journey. And for upward journey, I'm plotting the graph. If I plot the graph, acceleration is constant but negative. So this is AT graph. This graph is like this. It is negative but constant. So this is regarding the vertical projected body graphs. So today in this video, I explained, so what is a vertically projected body, and then what are the conditions required for a body to project up. Then we'll discuss some real-time examples in this. Then we discussed about the equations of motion, time of ascent, time of flight. Then we discussed about the maximum height and some important points to ponder, very, very important. Then we discussed about the body projected from the top of a tower. Then at last we discussed about the graphs. So this all for this particular topic. In the coming video, I'm going to discuss about the applications of bodies under gravity. Thank you for listening. And if you really like my content, please share my videos and channel. Please subscribe my channel and leave your comments below the videos. And do not forget to click the bell icon for more updates. Thank you once again for listening and happy physics learning. Thank you once again.